Hello class, today we're going to talk about area of parallelograms and rectangles. Okay, so again, it is another PowerPoint, so let me get that set up for us. Let me turn on my pen here. Okay, so let's start off with a little warm up here. Let's kind of review multiplying all different kinds of things. So if we have whole numbers, it's no big deal to multiply those. What you need to remember is just take the larger looking number, put it on top, put the smaller looking number, multiply, just like we did yesterday with circumference, where we just multiply. 8 times 2 is 16, 8 times 1 is 8, plus 1 is 9. There's no decimal, so our answer is 96. Okay, but what if I have fractions? Okay, fractions, you can do one of two things. You can either change the fractions to decimals, or, you know, in the case of this 1/3, you can't do much with it. In order to multiply, you just have to have fractions. So the first thing we got to remember with this 3.5 is I got to make it into a fraction by doing the popcorn method. So we do 2 times 3 plus 1 to give us 7/2. Okay, and then we do 3 times 5 is 15 plus 1 to give us 16/3. And then to multiply fractions, you know you got them. It's top times top and bottom times bottom. So we multiply across, but we could also simplify before we multiply. Any top number can simplify with any bottom number, and we've been talking a little bit about that here lately. So this 16 and this 2 could simplify, okay, and that would turn into an 8 and a 1. Now we can multiply across and it gets a lot better. 7 times 8 is, I'm kind of moving over here a little bit, 56, and then 1 times 3 gives us 3. And then again, we simplify that down into a mixed number, and that's just a division problem. So we come over to the side and we do our division. 3 goes into 5 one time. We end up with 2 left over. We bring our 6 down. 3 goes into 26 8 times. We get 24, we get 2 left over, and because we're working with fractions at this point, since I ran out of numbers, I stop. My leftovers becomes our numerator, and the number that we're dividing by becomes our denominator. So this simplifies to 18 2/3. These are some skills that you will have to be able to use for our lesson today. It's multiplying all different types of numbers, and you have to remember how to do that. Okay, so today we're going to attempt to find area of rectangles and parallelograms. The nice thing is they use the same formula. Okay, so it should not be a difficult thing. So let's first off define area. What is it? Well, area of a figure is the number of unit squares needed to cover the figure. Okay, area is measured in square units. Okay, so when we look at area, first looking at area of a rectangle. The area A of a rectangle is the product, or we're going to multiply, of its length and its width, or sometimes we call it base and height. Okay, the formula that you will see on your formula chart for both a rectangle and a parallelogram is A is equal to little b h. Okay, and they mean basically the same thing. The length is our base, the width is our height, means the same thing. So we could think of this as our length and our width, or we could think of it as our base and our height, either one. And all we're going to do is what? We're going to find their product, which means we're going to multiply those together. Now, you've been doing area of a rectangle since 4th and 5th grade, so this should not be anything new to you. We're just kind of reviewing. Okay, so here we have a rectangle, and I want you to find its area. So the first thing I would like for you to do is you must write the formula down. A is equal to LW, or A is equal to BH. It makes no difference to me which formula you use. Okay, so A equals. Now, because I'm multiplying my length and my width, it doesn't matter which number I put where. So it's just going to be 7.4 times 4.5. So I want you to write that down, then go over to a side spot and actually multiply those. Okay, so we line up our numbers. Remember, we don't line up our decimals. We just line up our numbers. Now we multiply. 4 times 5 is 20. Oops, put a 0 down, carry the 2. 5 and 7 is 35, plus 2 gives us 37. Okay, I move over a place here, so I move over a spot in the answer part down here. So I got 4 times 4 is 16, so I carry the 1, write the 6 down. 4 times 7 is 28, plus 1 is 29. And then we add 0, 7 and 6 make 13. 9, 10, 11, 12, 13. Carry the 1, we end up with 3. Okay, so we got 3,330, but now we got to figure out where's my decimal going to go. We'll have one number to the right in this number, one number to the right in this number, so that's 2 total. So my answer should be 33.30. Now, when we're dealing with area, like it said on the previous slide, our area is 33.30, or just 3. But what we're going to do is we're going to take our unit, whatever our unit happens to be, in this case inches, and we're going to square it. Because what I'm really looking for is how many little squares are found inside that shape that are of that size. So there's 33 1/3 inch squares inside that shape. Okay, so what I'd like for you to do is do one on your own. Okay, so pause the video and answer this question. Okay, so let's see how you did. First thing you should have written was A equals LW. A equals 8.2 times 6.3. A equals, and now we go over to the side and we multiply those two numbers together. 8.2, sorry about that, let me erase that there. 8.2 and 6.3. So 3 and 2 make 6. 3 and 8 make 24. Okay, I move over a spot. 6 and 2 make 12. 6 and 8 make 48, plus 1 gives me 49. So when I add that together, I get 6, 6, 9, 10, 11, 51.6 or 51.66. I've got one place here, one place here. So my answer is 51.66. It doesn't tell me any rounding rules. So that means my answer is 51.66. I look over at my label inches squared. And that's how we find the area of a rectangle. All right. Now, what if I gave you the area and asked you to find one of the missing pieces? Well, we could use the formula in reverse. It says the area of a playing field is 1,470 feet squared. And the length is 42. What is the width? So basically what we have here is we've got some kind of a field. I know its area, this part in the middle, is 1,470 feet squared. And I know that its length is 42 feet. What I'm looking for is the width. Okay, so when we look at this formula, A is equal to LW, I've got three things I can plug information into: area, length, and width. Well, in this particular problem, I know the area. So we end up with 1,470 as the A, and then I know the length is 42, and I'm looking for the width. So now we got to use our algebra that we remembered way back in the first semester to solve for W. So here I have a multiply by 42. So to get rid of that, I do a divide by 42. And if I do that to one side, I must do it to the other. So W then is equal to, now we go over to the side and we do our math. 1470 divided by 42. Well, let's see, 42 doesn't go into 1. Doesn't go into 14, but it does go into 147. And I bet it goes about 3 times. Okay, so 3 times 2 gives us 6. 3 times 4 gives us 12. We subtract. We get 1, 2, bring down our 0. And now 42 goes into 210. I bet that goes 5 times. So 5 times 2 is 10. 5 times 4 is 20, plus 1 gives us 21. Remainder of 0. So that tells us that our W is 35, but in this case, because it's just a distance, it's just 35 feet, because I already have an answer that has feet squared on it. So sometimes you may have to work the problem in reverse and find the missing part. So that's what we do with rectangles. Now what about a parallelogram? Well, a parallelogram, in my opinion, is just a squished rectangle. That's all it amounts to. It's a rectangle that's been pushed over. Okay, so this is where we talk about our base and our height. Now you could also refer to this as length and width. Makes no difference. Okay, but if you were to take this little rectangle right here, chop it off, and put it right here, you now have a rectangle. So that's why these are basically the same shape. Okay, so if I wanted to find area of a parallelogram, we're going to do the same thing. A equals. Now instead of doing length times width, we'll do base times height. So then A equals, our base is 16, our height is, and our height is always going to be defined as the perpendicular distance from the base to the farthest point away from the base. So in this case, this height is always going to be touched by that right angle. Again, we've talked about that before. We just multiply those together. So then we come to the side, we multiply 16 times 8, 48, 8 times 1 plus gives you 128. Right, so you end up with 128 meters squared. So let's have you answer one on your own. pause the video and answer this question. Okay, let's see how you did. Okay, you should have written the formula down. A is equal to base times height. A is equal to, well, the base is 12 and the height is 6. And again, your base and your height will always be touched by the right angle. And now we just multiply those together. 12 times 6, 6 times 2 is 12, 6, 7. We end up with 72 centimeters squared. And that's all you have to do in order to find area of rectangles and area of parallelograms. So now what I'd like for you to do is a little assignment doing the same exact thing. So you'll notice on this particular one, I'm asking you on the first 3 questions, just find the areas of each of those rectangles. So you'll notice in the first one we've got nice numbers, but in the second one we've got fractions. Okay, now you could just change each of those to decimals. We know 1/2 is just 0.5, so you could have this one be 18.5 and 7.5 and just multiply those. And then number 3 is just some decimals. Okay, number 4, 5, and 6 are the same thing. But we do need to remember and be very careful on number 5. I told you the base and the height will always be touched by a right angle. Okay, 7, 8, 9, same kind of thing. Just find the areas of those. And 10 and 11 are application kind of questions. Now when you look at number 11, this one says 70 ft2. That really is 70 feet squared. So that's one where I gave you an area, I gave you a dimension and asked you to find the other. So that's where you got to use the formula backwards. Okay, so at the end of class, we are going to turn this assignment in. So please pick up a copy of the assignment from the substitute, answer the question, show your work, and turn it in at the end. Until next time.